Merilena Jonnada, and I would be presenting um, about wireless communications today. So, wireless, just by saying or hearing the word wireless, makes us feel happy and satisfied. It makes us feel like everything is easy when it is wireless. But what exactly is wireless technology? Wireless technology is basically an invisible connection that gets established between the devices. Within a wired connection, we can see a wire that connects the devices to each other, but with wireless, everything happens without the physical connection. The connection gets established by transferring data between points using radio waves, infrared, acoustic, or optical signals. Something that looks and sounds so easy to us has too much going on in the back end. Almost every organization and individual are preferring wireless over wired connections, as wireless makes us get connected to things on the go. We want that flexibility while using the devices. We do not want to sit and plug in a wire to use things. This has made many organizations in developing many new devices and increase the connectivity strength and area coverage with their devices. Wireless technology can refer to various things, like wireless communication, which is a technology that enables the transfer of data over distances without physical cables, like Wi Fi, Bluetooth, and cellular networks. Wireless charging, which is the process of charging devices without using wires, typically through electromagnetic fields used in devices like smartphones and electric toothbrushes. Wireless networking, which is the setup and use of networks that allow devices to connect to the internet or local networks without physical cables, often using Wi Fi. Wireless audio is basically devices like wireless headphones or speakers that use Bluetooth or Wi Fi to transmit sound. Wireless sensors are devices that collect data such as temperature, humidity, or motion and send it wirelessly to a central system. So, what is a wireless communication? Wireless communication refers to the transmission of data over a distance without the use of wires or cables using electromagnetic waves. Wireless communication refers to the transmission of information such as data, voice, or video between devices or systems without the use of physical wires or cables. Instead of that, it uses electromagnetic waves such as radio waves, microwaves, infrared, or light signals to carry the data through the air or space. Wireless communication basically enables devices to send and receive information without the need for physical connections, making it a cornerstone of modern communication systems and essential for technologies like mobile phones, the internet, and Internet of Things. Some of the key features of wireless communication are the are that there are no physical cables. The information is transmitted using electromagnetic radiation. The transmission range can vary from a few centimeters, uh, for example, Bluetooth, to thousands of kilometers, example, satellite communication. Wireless communication is used in various fields, including mobile phones, the internet, satellite communication, television, GPS, and many more. Um, these are my research questions. Are there too many security concerns with wireless connections, and do wireless protection methods work to provide security? So, to answer the first research question, are there too many security concerns with wireless connections? Yes, security concerns are one of the significant challenges associated with wireless connections. While wireless communication provides convenience, mobility, and flexibility, it also opens up several vulnerabilities that can be exploited by malicious actors. Some of the key security concerns with wireless connections include eavesdropping and interception, unauthorized access, denial of service attacks, man in the middle attacks, WPS vulnerabilities like Wi Fi protected setup, Bluetooth vulnerabilities, location tracking and privacy concerns, Internet of Device, Internet of Things device security, physical layer attack. Um, so, mitigating wireless security risks. Despite these concerns, various methods can be implemented to improve wireless security. Encryption. We can use strong encryption protocols like WPA3, that's Wi Fi protected access, for Wi Fi networks to ensure that data is encrypted and unreadable to unauthorized users. Secure authentication to ensure that devices are authenticated using strong passwords. Multi factor authentication or certificate based authentication method. Network segmentation to separate sensitive networks from guest networks to reduce exposure to attacks on less secure devices. We can use VPNs, that's virtual private networks, that can help encrypt internet traffic. It also helps us in protecting the data when using unsecure networks like public Wi Fi. Regular firmware updates to keep wireless routers, devices, and IoT equipment up to date with the latest security patches to prevent known vulnerabilities from being exploited. Uh, Disable unnecessary services to turn off services like WPS, Bluetooth, or Wi Fi when not in use to reduce potential entry points for attackers. Monitor and audit networks to continuously monitor network traffic for unusual behavior and conduct regular security audits to identify vulnerabilities before they can be exploited. While wireless connections offer many benefits in terms of convenience and flexibility, they also introduce security risks that need to be actively managed. Using strong encryption, secure authentication, and following best practices for wireless network security can significantly reduce the risk of attack. However, users and organizations must remain vigilant and aware of emerging threats to wireless communication systems. Coming to my second research question, do wireless protection methods work to provide security? Yes, wireless protection methods can effectively provide security, but their effectiveness largely depends on the strength of the protocols, how well they're implemented, and whether they're maintained over time. Um, when implemented correctly, wireless security methods can protect against many common attacks and reduce vulnerabilities. However, it is crucial to follow best practices to ensure optimal protection. Some of the most common wireless protection methods include encryption protocols. They are like WPA3 and WPA2. So, WPA3 is highly effective and used with a strong password, and WPA2, while still secure, is somewhat weaker and should be avoided if possible, especially in sensitive environments. Encryption keeps the data transmitted over the network secure and unreadable by unauthorized users. Strong passwords. Strong password is crucial to protect against unauthorized access, particularly in Wi-Fi networks. Weak passwords can be easily guessed or cracked, leaving networks vulnerable. Multi-factor authentication. This basically adds an extra layer of security by requiring users to verify their identity using more than one method. While this is more commonly used for online accounts, integrating multi-factor authentication into wireless network devices and routers can significantly improve security by making unauthorized access more difficult. Virtual private network. A VPN can help secure communications over unsecured wireless networks by creating a private encrypted tunnel for data. This is especially important when using public Wi Fi, which is vulnerable to eavesdropping and other attacks. Firewalls and intrusion detection systems. Firewalls help to monitor and control incoming and outgoing network traffic based on predetermined security rules. Many modern routers come with built in firewalls, whereas intrusion detection systems monitor network traffic for suspicious activity, alerting administrators if potential attacks are detected. These systems are effective at blocking malicious traffic and preventing unauthorized devices from accessing the network, especially in larger or enterprise networks. Firewalls can prevent many types of attacks, such as DDoS or unauthorized remote access. Secure authentication methods. We can say WPA2 Enterprise and EAP are examples of security authentication methods. So WPA2 Enterprise uses more robust authentication methods, and EAP is a framework that supports various authentication mechanisms, offering better security than just using a password. Disable unnecessary services. Wi-Fi protect setup is often a vulnerability in routers, as it can be exploited via brute force attacks. Disabling WPS and other unnecessary services reduces the attack surface of the network and makes it more difficult for attackers to exploit vulnerabilities in the router or connected devices. Firmware and software updates. Regular updates fix known security holes and ensure that the wireless network is protected against the latest threats, such as zero-day vulnerabilities. The outdated devices are more prone to being compromised by attacks. Segmentation and network isolation. Network segmentation involves dividing the network into smaller parts to isolate sensitive information and critical devices from the rest of the network. This is highly effective in preventing lateral movement in the case of a breach. If one segment is compromised, the attacker cannot easily move to other parts of the network. And monitoring and alerts. Proactive monitoring can help identify potential security incidents before they escalate into major problems. Common challenges and limitations of wireless protection methods include human errors, security trade offs, legacy devices, and complexity. Wireless protection methods can work effectively to secure wireless networks, but they need to be properly implemented, configured, and maintained. Using strong encryption like WPA3, multi factor authentication, a VPN, secure authentication, regular updates, and monitoring can significantly reduce risks and enhance security. However, these methods must be part of a comprehensive security strategies, as each wireless network and its use case may require different approaches to ensure safety from evolving mitigation techniques. Mitigating security concerns in wireless communication involves adopting a combination of technical measures, user practices, and regular monitoring to reduce vulnerabilities and protect against common threats. Some key strategies to mitigate wireless security risk include using strong encryption protocols, mm, implementing strong and unique passwords, disabling WPS, using multi-factor authentication, regularly updating router firmware, using a VPN, segmenting your network, enabling firewalls and intrusion detection systems, disabling remote management, monitoring network traffic regularly, using strong authentication for devices and services, disabling unnecessary wireless services like Bluetooth in UPnP, uh, using secure communication protocols, educating users on wireless security, and keeping IoT devices secure. Mitigating wireless security risks involves a layered approach that includes strong encryption, secure passwords, network segmentation, regular updates, and monitoring. By implementing these strategies, we can significantly reduce the likelihood of wireless security breaches. Um, some types of wireless communications include radio communication, like in AM, FM radio or walkie talkies, cellular communication, like mobile networks, uh, Wi-Fi, Bluetooth connections, satellite communications, infrared communications, and Zigbee. Um, some common applications of wireless communication include mobile phones, Wi-Fi networks, GPS, wireless headphones, and IoT devices. Some key components of wireless communication systems. Transmitter, they are the devices that send the data. Um, for example, mobile phone or a Wi-Fi router. Receiver, it's a device that receives the transmitted data. For example, we can say maybe a laptop, smartphone, or satellite dish. Um, Channel is a medium through which the data is transmitted, which could be air, space, or the vacuum of space and satellite communication. Modulation, it's the process of encoding the information onto a carrier wave like radio or microwave, etc., which is then transmitted. Antenna is a device used to send and receive electromagnetic waves. Um, some advantages of wireless communications is mobility. It allows devices to be used and moved freely without being tethered by wires. Convenience, it reduces the clutter of cables, making devices easier to use and install. Flexibility, it enables communication over long distances in environments where running wires would be difficult, maybe remote areas or buildings with complex layouts. Um, Scalability, wireless networks can be easily expanded without needing to lay additional physical cables. Challenges in wireless communication, interference. Wireless signals can be disrupted by other devices or physical obstacles. Limited spectrum. There is a limited frequency spectrum which leads to congestion in wireless communication. Security concerns. As mentioned earlier, wireless networks are more vulnerable to security threats. Network capacity. As the number of connected devices increase, network capacity and bandwidth management become challenging. Signal propagation issues. Obstacles like buildings and terrain can affect signal strength and reliability. Uh, Drawbacks. While wireless communication offers numerous advantages such as mobility, convenience, and flexibility, it also comes with several drawbacks and limitations like security risk, signal interference, limited range, like short transmission range and weak signal and remote access, bandwidth limitations like limited bandwidth range, power consumption like high power usage and energy efficiency challenges. network reliability and stability, electromagnetic radiation, cost of infrastructure, limited data transfer speed, security vulnerabilities in public networks, difficulty in scalability, and signal loss. Future trends in wireless communication: 6G networks, they are expected to offer much higher speeds, better AI integration, and ultra low latency for applications like holographic communication. AI integration: AI will optimize wireless networks by managing traffic, improving security, and predicting network condition. Quantum communication: quantum encryption promises theoretically unbreakable security. Ubiquitous connectivity: efforts are underway to ensure constant, seamless wireless coverage worldwide. Edge computing: by processing data closer to the source, edge computing reduces latency and bandwidth usage. Wireless communication security. This wireless communication security basically refers to the measures taken to protect data, devices, and networks that rely on wireless technologies from unauthorized access, malicious attacks, eavesdropping, and other security risks. Given the dynamic and open nature of wireless communication, um, ensuring its security is crucial for protecting sensitive information and maintaining the integrity of the communication process. Some key security concerns in wireless communication include eavesdropping, like wireless signals can be intercepted by anyone within range, making it easier for attackers to access sensitive data. Unauthorized access, like attackers can attempt to connect to a wireless network without authorization, gaining access to devices, information, and resources. Man in the middle attacks, attackers can position themselves between two communicating parties to intercept, alter, and inject data into the communication stream. Denial of service attacks, wireless networks can be targeted by DOS or jamming attacks, disrupting communication by overwhelming the network with unnecessary traffic or noise. Rogue access points, attackers may set up fake access points that mimic legitimate networks to deceive users into connecting. Once connected, the attacker can capture or manipulate data. Replay attacks, attackers may capture and replay previously sent messages to trick the system into accepting them as legitimate, leading to unauthorized access or commands being executed. Um, Challenges in wireless communication security: interception and eavesdropping. Wireless signals can be intercepted more easily than wired signals, making data vulnerable to unauthorized access. Unauthorized access without proper security measures, unauthorized users can gain access to wireless networks. Man in the middle attacks. Attackers can intercept and alter the communication between two parties. Jamming and denial of service. Attackers can disrupt communication by flooding the network with excessive signals or intentionally blocking wireless communication channels. Signal spoofing. Fraudulent networks such as fake Wi-Fi hotspots can mimic legitimate ones, tricking users into connecting and exposing them to data theft. Wireless protection methods. Wireless protection methods are techniques and strategies used to secure wireless networks and communication systems from unauthorized access, data breaches, and various types of cyber attacks. Since wireless networks are inherently more vulnerable than wired ones, um, employing strong protection methods is crucial to safeguarding sensitive data and ensuring network integrity. Some of the primary wireless protection methods include encryption, virtual private networks, VPNs, authentication firewalls, and intrusion detection systems. So, encryption is one of the most crucial wireless protection methods as it helps secure data transmitted over wireless networks by making it unreadable to unauthorized users. Since wireless communication involves data being transmitted over the air, encryption ensures that even if someone intercepts the signal, they cannot access the data without the proper decryption key. So, how encryption works in wireless networks? When data is sent over a wireless network, encryption converts it into a scrambled or unreadable format. Only authorized devices with the correct decryption key can translate it back into its original readable form. Encryption prevents eavesdropping and protects sensitive information from being exposed or stolen. Um, Types of wireless encryption protocols. Different wireless encryption protocols are used to protect data, each offering varying levels of security. Common protocols include WPA2 and WPA3. Uh, Encryption is a fundamental wireless protection method that ensures the confidentiality, integrity, and authenticity of data transmitted over wireless networks. WPA3 provides the strongest encryption available for securing wireless communication, protecting against eavesdropping, tampering, and unauthorized access. For maximum security, it's essential to use modern encryption protocols, strong passwords, and up to date devices and software. VPN, virtual private network. Um, a VPN is a powerful wireless protection method that enhances the security and privacy of wireless. It encrypts internet traffic and hides your real IP address, making it one of the most effective tools to protect data from being intercepted and ensuring secure communication over wireless networks, particularly in untrusted or public environments. How does a VPN work? A VPN creates an encrypted tunnel between your device and a remote server operated by the VPN server. All internet traffic passing through this tunnel is encrypted, making it difficult for anyone, including hackers and malicious actors on the same network, to eavesdrop on or intercept your data. A VPN is an essential tool for securing wireless communications, particularly when using public or untrusted networks. By encrypting internet traffic masking your IP address, and providing a secure tunnel for your data, VPNs prevent hackers and other entities from intercepting or snooping on your online activities. Additionally, VPNs help protect privacy, allow users to bypass geo restrictions, and enable secure remote access for businesses. However, it's important to choose a reputable VPN provider to ensure that your privacy is maintained while using the service. Authentication. Authentication is a critical wireless protection method used to verify the identity of the devices or users trying to access a wireless network. It ensures that only authorized devices or individuals are allowed to connect to the network, thereby preventing unauthorized access and protecting sensitive information. Authentication is one of the first lines of defense in securing wireless networks, and it is often used in combination with encryption to provide comprehensive security. What is wireless authentication? Wireless authentication is the process of verifying the identity of a device or user trying to connect um, to a wireless network. The goal is to ensure that only legitimate users or devices are granted access, preventing unauthorized access to the network or its resources. Authentication is typically achieved through the use of a combination of user credentials, like usernames and passwords, device identifiers, or security tokens, and plays a central role in wireless security protocols like WPA2 and WPA. Authentication is a vital part of wireless protection because it verifies the identity of users and devices attempting to connect to the network. Um, so methods like WPA2 Enterprise and WPA3 Enterprise provide strong, secure wireless authentication, ensuring that only authorized users can access the network. Combining authentication with encryption methods enhances overall security, protecting against unauthorized access, data breaches, and other firewalls and intrusion detection systems. So firewalls and intrusion detection systems are critical components of network security designed to protect networks and systems from malicious activities. They function as the first line of defense against cyber threats, monitoring and filtering incoming and outgoing traffic. A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Its primary purpose is to establish a barrier between a trusted internal network and untrusted external network, such as the internet. Some types of firewalls include packet filtering um, firewalls. So these operate at the network layer and examine uh, packets of data to determine whether they should be allowed or blocked based on predefined rules. Stateful inspection firewalls. This tracks the state of active connections and makes decisions based on the context of traffic. Um, and proxy firewalls, these act as an intermediary between users and services, forwarding requests on behalf of the user. And next generation firewalls, these combine traditional firewall features with additional functionalities such as deep packet um, inspection, intrusion prevention systems, application awareness, and filtering. Um, Firewalls help in preventing unauthorized access, um, protect internal networks from external threats. They help in controlling traffic to enable fine grained control over network traffic. They help in monitoring and alerting, track potentially malicious activity, and provide alerts. They also help improve network performance by blocking unnecessary traffic, which in turn reduces the burden on the network. Whereas the detection system is designed to detect unauthorized access or malicious activity within a network or system. It monitors network traffic or system behavior to identify any suspicious actions that could indicate a potential security breach. Some types of intrusion detection systems include network-based intrusion detection system. These monitor network traffic for signs of suspicious activity or security breaches. Host-based intrusion detection systems. Um, these are installed on individual devices to monitor and analyze activities occurring on that particular machine. Signature-based intrusion detection systems. These are used like they used to predefine signatures or patterns to identify known attacks. Anomaly-based intrusion detection systems establishes a baseline of normal network activity and alerts when deviations from this baseline occur. Hybrid intrusion detection systems combines both signature-based and anomaly-based detection methods, offering a more comprehensive approach to detecting known and unknown attacks. Some key features of intrusion detection systems include real-time monitoring, threat detection, alerting and logging, and forensic analysis. And some benefits of intrusion detection systems include early threat detection, minimizing damage, continuous monitoring, and assisting in compliance. While both firewalls and intrusion detection systems are important components of comprehensive security strategy, they serve different functions. Firewalls will block unauthorized access based on security policies, whereas intrusion detection systems will detect and alert administrators to potential threats that have bypassed the firewall or originated from internal sources. Securing public wireless networks. Risks of public Wi Fi. Public wireless networks are often insecure, making users vulnerable to eavesdropping, data interception, and malware attacks. Some of the best practices includes using a VPN. Uh, Always connect through a VPN to ensure secure data transmission. Uh, Avoid sensitive transactions. Refrain from accessing banking or personal accounts over public networks. Enabling HTTPS. Ensure websites are using HTTPS to encrypt the data between the website and your device. Uh, Forget the network after use. Disable automatic connection to public Wi-Fi after use to avoid unwanted connection. Um, Future of wireless communication security. AI and machine learning. AI will play a major role in identifying and mitigating potential security risks in real time. Quantum cryptography. Quantum computing may break current encryption algorithms, making quantum resistant encryption crucial for future networks. Zero trust networks. A security model where every device and user is considered untrusted until verified, reducing the risk of internal breaches. Network automation and self-healing networks. Um, Future networks will likely use automation to respond to security threats, and self-healing systems may be used to repair security breaches quickly. Um, these are the references that I referred to from my research. Any questions?